I rewrite this as -1 times the integral of 1, and then if I change this, that would become a minus, this would become a plus, right? If I pull a negative out. So I could write it this way. Right? That's the same thing, right? 1 over 9 minus x squared is the same as -1 times 1 over x squared minus 9. And I could just write this down, right? So isn't our answer that with a -1 in front? Or you could use the formula. What's the only difference between these formulas? What's the only difference?
Changes the numerator or denominator.
Those switch places, right? Do y'all see where that would come from? Imagine there was a negative here. Property of logs. That negative could come up here as a power, and then a fraction to a -1 would be the reciprocal. I just gave away part of your quiz right there. Because I said there's an easy way to do the last one or a hard way. That's the easy way. Okay, I'll see if you can figure that out. So can we handle a constant over a quadratic if it's missing the x term? Can you think of any other combination that we could have that might cause an issue? I mean, I've shown you with the pluses between them, where this number is not a perfect square. I've shown you where you have a number in front of that x squared and you have to factor it out. Can you think of any other issues we might have with a constant over a quadratic that's missing an x term? Yeah? So theoretically, constant over linear, good, right? Constant over repeated linear, good. Constant over quadratic that's missing an x term, good. All right, what about a constant over a quadratic that does have an x term in it, and that quadratic on the bottom is irreducible? Now, what do I mean by irreducible? Not factorable, okay? That's basically all that irreducible means. So we are looking at a constant on top over a quadratic on the bottom that cannot be factored. Okay? That cannot be factored. Do y'all agree we can't factor that denominator? You're not going to be able to come up with two numbers that multiply to be 17 and add up to be 2. It's not going to happen. If this was factorable, okay? If this was factorable, we would be able to do it using what we're going to learn next class. All right? Which is the whole reason we're going to learn what we're going to do next class, is we want to be able to handle things like this when we can factor them. But let's talk about when we can't first. If we can't factor it, what do we do? So are you ready? I'm just going to tell you what it is. Pretty straightforward. Complete the square. Okay? You're just going to complete the square in the denominator. So I'm going to take x squared plus 2x plus 17 over here, and I'm going to complete the square. We talked about this last class, right? What's the first thing you need to be able to complete the square? Yeah, make sure in front of the x squared you have a 1, which we do, right? Now what? Divide the middle coefficient by 2. So I'm going to take the 2 that's in front of the x, divide by 2, that gives me 1. Then I take that answer and square it, and I get 1 again. That's my magic number. There's 2 of them, right? I'm going to take 2x, x squared plus 2x. I'm going to add this number, subtract that number, and then I still had plus 17 there, right? So I'm using this number right here, adding it and subtracting it. The first 3 terms, guaranteed, perfect square trinomial, it will factor to be what squared? X plus that number, right? So x plus 1 squared, and then the rest of this is plus 16. Okay? You with me?
Yes.
Okay. So I can rewrite this as 1 over x plus 1 squared plus 16 dx. Can't I? That's just me completing the square. I'm just writing it a different way. You all see where I'm going with this? Where am I going?
Make u x plus 1.
Make u x plus 1? So imagine that that's a u, and then what can you do?
You can do the tree.
The formula 17, right? So we all have to see at this point right here that this is linear in here. You see that? And so if I call this u, do you all see that this is 1 over u squared plus a squared? The only thing I'd have to be worried about is if possibly there was a number in front of this x, like maybe if there was a 3 in front of that x, we wouldn't have to scale by 1/3. But I don't have that. I just have x plus 1. So can I just go straight to the formula? So formula 17 is 1 over a. What's a for us? 4. Formula 17 is arctangent, right? And this is the part that you have to be careful with. Arctangent of what? The formula says u over a, right? What's u for us? X plus 1. It's the whole thing, right? This whole thing. So this is x plus 1 over 4. That only works because this is linear in here, right? What we're not showing, what I'm not showing is that you could, if you wanted to, do a basic u sub. And if you do that, this whole problem becomes integral 1 over u squared plus 16 du. Oh, it's off. Watch out. Heads up. Do you mind throwing that away for me? That looked a lot. I just felt it felt good. Thank you. Do y'all see this? That's what I actually did. And then did this formula and then replaced the u's with x plus 1. That's constant over an irreducible quadratic. You complete the square and then you use formula. Well, it's not always going to be formula 17. It could possibly turn out that this was like a minus 16 here, but then you'd use one of the other ones. Okay? Good? All right, here we go. This one right here is one that, well, there's two major approaches to this problem, all right? There's the approach that the book's going to use and that most tutors are going to use, and then there's an approach that I like. So I'm going to show you the approach that I like first, and then if y'all hate it, I'll show you the other approach as well, all right? So look at this problem. It's different than anything we've had up to this point. Why is this different? We have a linear expression in the top. Everything we've done up to this point has been a constant up top, right? Now our numerator is linear, and our denominator is an irreducible quadratic. Now, it's irreducible. You'd have to check for yourself. 4x squared minus 4x plus 3 does not factor, okay? So I'm looking at this. I'm got linear over an irreducible quadratic, and I'm trying to figure out what to do, right? So think about this. My Cal 1 class, we were talking about this the other day. When you have a polynomial, like the denominator is a quadratic, right? A quadratic is a polynomial. Yes. The derivative, when you take derivative of a polynomial, the power comes down by 1, doesn't it? So if you take the derivative of a quadratic, you should get a linear expression, right? So my denominator is quadratic and my numerator is linear, right? So wouldn't it be beautiful if the numerator was actually the derivative of the bottom? In other words, like if you just let the bottom be u, it's quadratic, and then take its derivative and get a linear expression, wouldn't it be great if it was what was up top? That'd be great, wouldn't it? All right, so let's see. If we have this, I'm sitting here going, okay, up to this point, I don't know how to handle this, right? But I'm going to hope for something, right? I'm going to say, look, let me just let u, basic u sub, no trig sub, this is basic u sub. Let me let u be the bottom. And then let me take the derivative of that. The derivative of this would be 8x minus 4, right? And put that in parentheses dx. That's the derivative, right? Yes. I would love to see 8x minus 4 up top, right? What if it was 8x minus 4? What if it was? What would this turn into? If this was 8x minus 4, wouldn't this just be 1 over u du? And then the answer would be natural log of that, right? Question? Can you scale by 4? What do you mean scale by 4? Divide this by 4? If I did divide that by 4 on both sides, you would get 1/4 here, dx. And this would be, what, 2x minus 1 dx? Do we have that there? We don't, right? We're a little bit off. Good idea, but we're off.
Did you mean du?
Uh,
On the left side.
oh, I did mean du. Thank you.
So we can,
Thank you.
we can multiply
du.
the derivative by both the top and the bottom.
Yeah, so
Is that what you're going to?
what I want everyone to see right now is that, okay, this almost worked, right? The 1/4 here, this almost looks like up there, but it's not, right? So we're kind of stuck. What I was hoping for isn't happening, right? I was hoping that the numerator would be 8x minus 4, right? I'm going to make it become 8x minus 4 now, right? That's what I want. I'm going to make it happen. You ready? So everything I do right now is just going to be algebra, and I'm going to try and make x minus 1. This didn't work, so I'm going to erase it. Is that okay? But it was good to try, because that would have been nice if that turned into x minus 1. Then it would be basic u sub. So I would really like an 8x, wouldn't I? I'll take care of the minus 4 in a second, but I need an 8x. I need that to be an 8 in front here. The only way to do that is to multiply the top and the bottom of the integral by 8 over 8. I can do that, right? That's a 1. And what I'm going to do is I'm going to leave the 8 in the denominator on the bottom, and I'm going to distribute this 8 through the top. And then let's look at our new integral. So I have now 1/8 out front, right? Because I left the 8 on the bottom out here. The 8 passed through the top, 8x minus 8. Don't forget, it's got to go to both of them, over 4x squared minus 4x plus 3 dx. Is that okay, everyone? Now, I wish it was an 8x minus 4, right? I have 8x now, but I have minus 8. So here's what I'm going to do next. And there's a couple of ways to do this. To me, this is the safe way to do it so that you don't get yourself into trouble if the numbers aren't so nice and clean. I want what? 8x minus 4. So I'm going to say that. I'm going to put minus 4. And guess what I'm going to put next to that? Not minus 4, plus 4. Really what I'm doing here is I'm taking away something and adding it. So this is like a 0, isn't it? Now, what did I really still have up there, though? I had 8x minus 8, right? So I still need that up there. Do y'all see that I have not changed the problem at all? That's the exact same problem. That's the same problem, isn't it? I know this looks weird, okay? But just follow me through, okay? This is going to get us somewhere. Now do you see 8x minus 4 on top? Yeah, but you also see this, don't you? All right, don't worry, I'm going to take care of it. All right, so this is going to become, all right, let's not forget we have a 1/8 out front integral. Now check this out. This is the cool part. 8x minus 4 over 4x squared minus 4x plus 3 plus negative 4 over 4x squared minus 4x plus 3 dx. Is that the same problem? Yeah, so what I've done is I've chosen to group these two together, right? And put that over this denominator, and then group those two together and put that over this denominator. So I've created two fractions, right?
What happens to the minus 8 on the...
Write these two together. Plus 4, take away 8, minus 4, and that's what I put over there. Why did I do this? Do y'all see why I did this? This one right here now, by itself, right? Because I've separated this and there's a plus between them, I can do these individually, right? This one right here is what I hoped it was from the beginning, right? It's just 1 over u du. This is going to be super easy to do. Do y'all see that? And this one is a constant over an irreducible quadratic, and I can complete the square on that one. You see that? So I'm not done, but I've now made it doable by transforming the numerator into what I was hoping it would be, or what I was really wanting it to be. All right? So let's continue. Yes?
We're not going to cover the splitting it into A plus B plus C, not yet.
A plus B plus C?
Oh, like
What are you talking about?
portion fraction.
No. We're building up to that.
Building.
Yeah, we're not ready for partial fractions. You can't do partial fractions on this. It's not factorable. Well, if you did partial fractions on this, the goal in partial fractions would be to try and get a linear expression on top. That would be the goal in partial fractions. If you had a quadratic that you can't reduce here, you try and get a linear expression on top, which we already have. So this would be the final step of a problem we do next class. Right? Next class, everyone, we'll work a problem, and this will be one of the pieces of it. And we'll be like, oh, and we know how to do that. It's all this, right? You know? But we'll get it to a point where we can now handle it. All right, so I'm not done here, right? I'm going to split this into two separate integrals completely and then do each one. I still haven't shown you the other way of doing this problem, so I'll show that to you, okay? And you can tell me which one you like more. You're not going to hurt my feelings. I know you. I know you're probably not sold on that after last class, but okay, this dx. Okay, what about this 1/8? That 1/8 is going to have to apply to both of these, right? So when I take that 1/8 to this one, I'm actually going to pull that -4 out. Is that all right with everyone? So this should actually be minus what? A half. Integral, and then 1 over 4x squared minus 4x plus 3 dx. Okay. When I distribute this through, right, this 1/8 is on this integral, and if I split it into two integrals, right, I'm going to have another integral here, it'll be 1/8, and then that -4 is going to come out and join that -4 over 8, -1/2. Question? All right, this one right here shouldn't require much thought because this is like what I was hoping for, right? This was me making the substitution u is 4x squared minus 4x plus 3. The derivative of that would be 8x minus 4 dx, which is exactly what I have on top. And so this turns into 1/8 integral of 1 over u du. So the answer should be 1/8 natural log of u, right? So I'm going to just keep going here. This is equal to this answer, 1/8 natural log of u, okay, minus 1/2 integral. I haven't done this one yet, right? Still working on this one. All right, how are we doing on time? All right, good. All right, how do we do that? How do we do that second integral?
You get x squared minus x plus 3 over 4.
We got to complete the square here, right? Don't we? Which means we need a 1 on that. Would y'all like to pull a 4 now?
Sure.
I don't mind. We can pull the 4 right now if you want. Let's do it. Can I leave this here and come back?
Yeah.
Okay. I'm going to just come over here and do like some scratch work. All I'm going to do is I'm going to take this integral right here. I'm even going to leave the -1/2 over there. So I'm going to just do this integral 1 over, I'm pulling a 4 out of the bottom, 1/4. Now that leaves me with x squared minus x plus 3/4 dx. You'll need to complete the square, yeah? Let's do that on the side. Ooh, you're going to have fractions. I'm completing the square on x squared minus x plus 3/4. So the number in front is a -1, right? So I take half of it. That's my first number. Then I take that number and I square it. That's 1/4 positive, right? I'm going to add and subtract that number right after this -x. So x squared minus x minus 1/4. Oh, sorry, add it and subtract. Did I say subtract and add?
Do we just do the constant then? So I had it over x over 2 by doing the middle term, but yeah.
It's the coefficient only.
Coefficient.
Yeah, for completing the square, it's only the, God damn it, I'm sorry. I don't know why. It's only the coefficient, yeah. Okay? What does this turn into? Are y'all all right? Yeah?
We're getting messages on phone calls. There's an evacuation drill at the main hall and.
Ah, shit, that's right. Yeah, it's not in here though, right?
No, it just says main.
Ours is, this building's Thursday at 2 o'clock. Nobody's allowed on their phones during class, so we didn't know that there was an evacuation. I don't hear any alarms. Okay, let's keep going, right? So x, what does this turn into? These three terms factor to be x, that number, right? X minus a half squared, and then you have to put these two together. Plus 2/4, so 1/2. Okay, yes?
About these magic numbers,
Yes.
okay, so we're supposed to use the squared every time to
This,
split it in the middle.
the square, this number right here, we're going to add and we're going to subtract that second number, which will always be this number squared, okay? And then when you once you do that, these first three will always factor to be x, and then this number is always going to be that number. Yeah. No textbook's going to call them magic numbers. I don't even know why I call them magic numbers. They're not magic. They're just numbers. But all right. So keep going. Yes. Another question or no? 1/4 integral. The whole point of that was to turn this into this, right? X minus a half squared plus a half dx. This is formula 17. Yes?
What if we have different coefficient on x squared?
What if you have a different coefficient? Like what? Like a number here?
Yeah, like
Well, we did actually. Remember, we had a 4 here. And we just pulled it out, right? Earlier we pulled it out so that because I knew I was going to complete the square, so I just pulled that 4 out. You could have waited and done it here, but then you would have had a 4 in front this whole time and then keep track of it. You might have lost it somewhere. All right. Do you all see that I can use formula 17? This is my u. It's linear. Do I have to scale by anything? No, there's a 1 in front of the x. So this is just like a u squared plus a squared. What's a?
So it's just
1/4.
Careful.
square root of 2.
1 over root 2. The square root of that is a, right? If that's a squared, then a is the square root of that. So a squared is 1/2. So a is square root of 1 over 2, which is 1 over root 2. And you could rationalize, but I don't rationalize. So I think I'm ready for formula, yes? Okay, let's come back over here. I'm ready to plug this in. It's this minus a half times a 4th, right? Don't forget we had a 4th here. Times now the formula for this. 1 over a, right? 1 over a, so 1 over this number, which is really just flipped over, right? So that's just going to be root 2. That's 1 over a. Inverse tangent, right? Is formula 17. And then u over a. U for us is what? X minus a half, right? X minus a half over a, but a was 1 over the square root of 2 plus c. I'm done.
You can
Yes.
square root of 2x.
You could flip that up and bring a root 2 in front of here and on top here,
Yeah.
if you want.
Okay.
Yes.
That root 2, that's also a 1 over root 2, right?
Yep. Yeah, that could. Here's just another way you could write. I'm happy with that, but you could write this as root 2 over a negative, root 2 over 8. That's putting all those together, right? And then inverse tangent of this right here, you could flip the root 2 up and multiply root 2, right, over 1 through to both of those. And you could get root 2x minus root 2 over 2 plus c. That's another version of the answer. I don't care. I'll be able to look at it when you take the test. I'll be able to see if you did it right or not. That problem took a little while, huh? A lot going on there? That was a linear over an irreducible quadratic. Now, would you like to see this done the other way? Another way? Or are you all happy with this?
Isn't that for getting the 1/8 natural log?
No, well, no, I'm saying this right here, right? This comes with this. Yeah, I carried it down. I'm just saying this part right here becomes this. Maybe I shouldn't have boxed it, but don't forget to include that. Yeah? Do you want to see another approach? I don't care. You want to see? I don't know. I mean, to me, okay, I'll tell you this. I think you might find the other way easier, maybe. I don't know. To me, this is more like, it requires, I guess, a different sort of thinking, you know, to be like, hey, I really wish that was this, and then make that happen, right? As opposed to something that's more mechanical where you're not really thinking, you're just like following a procedure. So I like this more in terms of you being a critical thinker. But let's do the other way, just to see it. Okay, the other way. And again, if you go get a tutor to help you, this is what they're going to do. Most likely, this is what they're going to do, because it's the way they were taught as well. All right, so what we're going to do, golly, is that still the school? All right, so what I'm going to do here, I'm going to say, okay, I've got linear over irreducible quadratic. I'm going to start by completing the square. I'm just going to start by completing the square. So I'm still going to pull a 4 out of this. And then when I pull the 4 out, right, I go through all the completing the square. We already know where what this turns into. Yes, I'm not going to go through all this work.
Right.
So this is what it turns into. X minus, wait, hold on. Yes, on the bottom, that's what it turns into, right? X minus a half squared plus 1/2 dx. Do y'all see this is not formula 17? Because we have x minus 1 on top. Over here, we just have 1, right? By the time we got to over here, right, the way I did it, this was a 1 on top, then we could use formula 17. Here we don't have that, do we? But you can still do this completing the square. Now what we do is we make a substitution. U is equal to x minus a half. So I'm going to make that substitution right there and replace this with x minus, that's going to become a u, all right? So let's do that. If we do that, then du is dx, right? Yeah? And this will be replaced with u, right? So this will be u squared plus a half. I need to replace this with something in terms of u. So I need to solve this for x, right? So solve that for x, you get x is equal to u plus a half. Yeah? So here's where we are. Equals 1/4 integral. The numerator is x, right, which for us is u plus a half minus 1. U plus a half minus 1 over, the bottom here is u squared plus a half du. And these two can come together, right? That's really just u minus a half up there.
Can we have just put a 2u up there? I don't know, maybe.
A 2u.
I mean, because if we were trying to define x minus 1, I don't know, I may be looking at this one. I regret my question.
Pull it back?
Yeah.
Okay, all right. So u minus a half over u squared plus a half du. All right? Do y'all have questions on what I've done? Do y'all see, I mean, where we're at? We still have a linear over a quadratic, right? But now notice our quadratic doesn't have a middle term. Doesn't have, like in our original problem, we had linear over a quadratic that was irreducible, right? Here we have a linear over a quadratic where the bottom is missing the u term. This is a little different than that now, right? It looks different. And what we can do now is we can split this into two integrals. Okay? Two integrals. The first one is going to be just integral u over u squared plus a half du. And then the second integral, I'm going to still have the 1/4. I'm going to say plus a fourth integral. I have the negative 1/2 over u squared plus a half du. Yeah, I'm going to bring it out. Do y'all see I just split it into two? All right, look at this first one. How do you solve this? Just a basic u sub. You would well, you can't use u, right? Because we've already used, but we could call this just a basic substitution. I would replace the entire denominator with, let's say, w. What's the derivative of this? What's the derivative down here? 2u. And we have that, but we're off by a constant. So we could do this with basic substitution, right? And then this, if we pull this out, this is going to be constant over variable squared plus constant squared. We could do that with formula 17. So we're there, basically. Yeah? You like the other way? Yes? Yeah, we can take that half out. Let me do that right now. Let's make this a -1/8. Like that. Do y'all see right here, this is formula 17, like right now, this is formula 17.
Yes.
But then you'd have to replace u at the very end with x minus a half. This one is a basic u substitution. Can I stop or do you want me to continue? What do y'all want to do? You want me to stop? Okay. I don't like this way. Again, because it's just personal preference. Let's do another one of these. Let's do one more, okay? I'm just going to make one up. I have no idea what's going to happen here. Let's go with 3x plus 2 over 5x squared minus 3x plus 1 dx. You're looking at a linear expression, right, over an irreducible quadratic. Right? So you have to see that. Linear on top, quadratic on the bottom, irreducible. This doesn't factor. So, make our substitution, right? U is the bottom. I really wish the numerator was the derivative of that. So the derivative of this is 10x minus 3 dx, right? So I need to make that, ooh, I made this a good problem. I need to make the top a 10x minus 3. By the way, you cannot